Stop. Whatever you're doing right now, just stop for 1 second. Feel that warmth on your skin, that light coming through your window, hitting the side of your face, casting shadows across the floor. That light didn't start this morning. It didn't begin when the sun rose a few hours ago. It didn't originate yesterday or last week or last year. The sunlight reaching you right now began its journey somewhere between 40,000 and 170,000 years ago, deep inside the core of the sun, long before humans had written language, long before we built our first cities, long before recorded history existed in any form whatsoever. And yet, once it finally escaped the sun's surface, it crossed 150 million kilometers of empty space and arrived at your doorstep in just 8 minutes. 8 minutes. After 100,000 years. That is one of the most staggering facts in all of science, and almost no one ever stops to really think about what it means. Today we're going to fix that, to understand why sunlight takes so long to reach us. Not the 8 minutes part, but the part that happens before that. We have to go back to the very beginning. Not just the beginning of the sun, but the beginning of everything that became the sun. About 4.6 billion years ago, the solar system didn't exist. In its place was an enormous, cold, slowly rotating cloud of gas and dust drifting through space. And this cloud wasn't made of fresh material. It was wreckage, the scattered remains of stars that had already lived full lives, burned through their fuel and exploded in massive supernovae that seeded the surrounding space with everything they'd built. That means the hydrogen inside the sun right now, the fuel it runs on, is ancient beyond comprehension. It existed inside other stars before our sun was born. Every atom in our solar system has a history that stretches back billions of years before the Earth formed. Slowly, over millions of years, that cold cloud began to collapse under its own gravity. As it collapsed, it spun faster. The same physics that makes a figure skater spin faster when they pull their arms in. Material fell toward the center, compressed and heated. The outer regions flattened into a disk, the same disk that would eventually form the planets, the asteroids, the comets, everything. But at the center, something far more dramatic was happening. The pressure was building, the temperature was climbing. And when that central mass reached approximately 15 million degrees Celsius, a threshold that sounds almost fictional, something switched on that had never switched on in this region of space before. Nuclear fusion began. Fusion is the process that powers every star in the observable universe. It is, in the most literal sense, the engine of existence. Here's what happens. Inside the sun's core, hydrogen nuclei, individual protons, are moving so fast and pressed so tightly together that when they collide, they don't just bounce off each other. The strong nuclear force takes over. They stick, they combine. 4 protons, through a chain of reactions, fuse into a single helium nucleus. But here's where it gets extraordinary. If you took 4 protons and weighed them, then weighed the helium nucleus they produce, you would find that the helium nucleus is slightly lighter. Not by much, a fraction of a percent, but that tiny bit of missing mass doesn't just disappear into nothing. It converts completely and instantaneously into pure energy. This is Einstein's equation, E equals mc squared. Energy equals mass times the speed of light squared. The speed of light is already an almost incomprehensibly large number, 300,000 kilometers per second. Square that number and multiply it by even a tiny amount of mass, and you get an explosion of energy that dwarfs anything chemistry can produce by a factor of millions. The sun loses approximately 4 million tons of mass every single second through this process. 4 million tons. Gone, converted into light and heat and radiation every second without stopping for 4.6 billion years. That energy has to go somewhere. And this is where the story becomes strange, genuinely, almost unbelievably strange. The energy born in the sun's core, born as a gamma-ray photon, an intensely powerful packet of radiation, needs to travel from the core to the surface before it can escape into space. The distance is about 700,000 kilometers. Not that far in the cosmic scheme of things. But the interior of the sun is not empty space, it is plasma. Incomprehensibly dense, superheated plasma, a soup of charged particles so tightly packed that a photon of light can barely move before it collides with something. When that collision happens, the photon is absorbed by a particle, which then re-emits a new photon, but in a completely random direction. Random. Completely, utterly random. So imagine trying to navigate across a city, but after every single step, you are spun around blindfolded and forced to take your next step in whatever direction you happen to be facing. You might walk 1,000 steps forward, then 500 steps backward, then sideways, then forward again. You are moving constantly, but your actual progress across the city is agonizingly slow. This is what physicists call the random walk, and it is exactly what light does inside the sun. A photon bounces, gets absorbed, gets re-emitted in a random direction, bounces again, gets absorbed, re-emitted again, trillions of times, quadrillions of times. Each individual interaction happens at the speed of light, but the net progress outward toward the surface is glacially, almost impossibly slow. Scientists estimate this journey takes somewhere between 40,000 and 170,000 years, depending on the region of the sun and the assumptions in the model. The range is that wide because the physics of tracking a random walk through plasma of varying density is extraordinarily complex, but all models agree on one thing. We're talking about time scales that dwarf human civilization many times over. The light finally makes it to the surface, and then, free at last, it accelerates into open space. 8 minutes later, it hits your face. Now step back and look at what the sun actually is, because most people carry a fundamentally wrong picture of it in their heads. The sun is not a fire. This is one of the most common misconceptions in popular science. Fire is a chemical reaction. It requires fuel, yes, but it also requires oxygen, and it produces carbon dioxide and water as byproducts. The sun has no oxygen. It does not burn in any chemical sense. The sun is a gravitational fusion reactor, a sphere of plasma so massive, 1.3 million Earths could fit inside it, that its own gravity crushes its core to conditions where fusion becomes not just possible, but inevitable and self-sustaining. And it exists in a state of extraordinary balance. Gravity is always trying to collapse the sun inward. The weight of the outer layers presses down relentlessly toward the core, but the energy released by fusion pushes back, creating outward pressure that exactly counteracts the inward pull of gravity. This balance is called hydrostatic equilibrium, and the sun has maintained it with remarkable stability for 4.6 billion years. That stability is not an accident. It is a self-regulating system. If the core gets slightly hotter and fusion speeds up, the sun expands slightly, which reduces the pressure, which cools the core back down. If the core cools and fusion slows, gravity compresses it again, raising the temperature until fusion resumes at the right rate. The sun breathes almost. A living machine balanced on the knife's edge between collapse and explosion, locked into a steady state by physics alone. And it is that steady state, that billions of years of consistent, reliable energy output that made life on Earth possible. Because here is what that energy actually does when it arrives. Every plant on Earth is a solar panel. Photosynthesis, the process by which plants convert light into sugar, is just captured sunlight being stored as chemical energy. The food you ate this morning was sunlight. The wood in your walls was sunlight. The coal and oil that powered the Industrial Revolution were sunlight. Ancient sunlight captured by organisms that lived hundreds of millions of years ago, compressed and stored underground for us to dig up and release. We don't run on fossil fuels. We run on ancient sunlight. Every calorie in your body traces back to a photon that was born in a nuclear reaction in the core of the sun, a photon that spent tens of thousands of years bouncing randomly through solar plasma before spending 8 minutes crossing the void of space and being captured by a leaf or a crop or a solar panel and converted into the energy that allows you to exist. So the next time you step outside into the sunlight, really stop, just for a moment. Those photons landing on you right now were created before the pyramids were built, before the wheel was invented, before humans had language. They survived an incomprehensible journey through the interior of a star, bouncing randomly for longer than our entire recorded history many times over. And then, in the final 8 minutes, They crossed the vast silence between stars and found you. The universe spent 100,000 years making that light. The least we can do is notice it.